the links right now. Okay, there we go. I was waiting for someone to start recording our meeting, so I just realized that they've started. Once again, I would like to welcome everyone for today's lesson. For today's lesson, um, so today the lesson is gonna be some form of a recap, or a revision of what we have done so far. So I want I want today's lesson to be mostly focused on doing example. As you can see, I want us to do as many examples as we can today, as many examples as we can. You know, Once again, I would like to welcome everyone who is just joining us. Today, guys, We'll be doing a revision for trigonometry, grade 10, revision trigonometry, grade 10. So we have touched on trigonometry. We have done trigonometric functions, you know. So basically, it's gonna be a revision for all of that, for all of that, from the basic trigonometric ratios, using trigonometric ratios to solve equations. And then, yeah, later on we will go into or we'll start by revising by doing examples for each this thing. Keep on trying to move pages, but it's acting up. I don't know why. I don't know why. Please just bear with me. Just bear with me as we are still waiting for others to join. We will start now. We will start now. We will start now. I just wanna. It keeps on messing this thing up. Let's hope this one works. Okay, finally. Now we have the space. Lesson 6. Lesson 6. This is a revision. This is a revision that we're gonna be doing today, guys. We're gonna be doing a revision. Matrix. Sorry. So today we are gonna revise everything we've done so far. Yeah, this thing. Okay. Yeah. So once again, welcome everyone. Hopefully you are here. We are able to hear my voice. If anyone is having trouble with that, please just text me or send a text on the group. To report that if for any reason my screen disappears. Also, just text me. Send a text on WhatsApp, because while I'm teaching here, I'm actually unable to sort of monitor the messages you may send on this particular app, you know. But yeah, as I've told you guys, that today is basically gonna be a revision for everything we've done in regards to trigonometry. Because before we move on to the next chapter, I would like for us to actually to make sure that we do as much examples as we can, because I believe that only not the only way, but the best way to actually learn and understand mathematics is by doing it. So the more you do it, the more you get used to applying these things, these principles of mathematics, is the more you become good at it. So math doesn't want lazy people. So if you are lazy, I have bad news for you. But all in all, let's get started, guys. I will quickly go through what we have introduced since the beginning. of this since the beginning of this series, if I may say, trigonometric series that we have been doing, and then yeah, up until the current point that we are at. So we have actually talked about trigonometry, and that it is basically the representation or the study of relationships between sides and angles. So that is the basics of trigonometry. The study of relationship between sides and angles. So that is what we deal with in trigonometry. So um so another thing that I introduced, since we have already touched on functions. So when we did functions, I actually told you guys that functions are basically relationships. It's the same thing that happens here. In trigonometry, we are still relating things. We are still relating side and angles. We are still relating um we have trigonometric functions which also relate certain quantities. We're relating certain variables. So it's all about relating things. It's all about relating things. Forget the fancy stuff. We're dealing with the relationship between numbers, a relationship between certain principles or certain ratios. So that is basically mathematics. you know so we introduce right angle triangle, the three sides of the right angle triangle, which is the hypotenuse side, adjacent side, opposite side. We introduced their identities. That's okay. The hypotenuse side is the side that is always facing the 90 degrees angle. Um, and then we introduce a certain angle in within the triangle, of which is mostly angle theta. And then we have the adjacent side, which is the side that's next to the angle. We have the opposite side, which is the side that is facing the angle that we introduced in the right angle triangle. And then we introduce the trigonometric ratios. We put a lot of emphasis on these three trigonometric ratios, of which is SOHCAHTOA. Those are very important. We use this even when we get into trigonometric functions. We introduce the reciprocals of the ratios, of which is cosec, sec, and cot. Also the conclusion, and then we also talk about the special triangles. The special triangles. So with the special triangles, we introduce these angles that have sort of these fixed values. Of course, each angle has its specific ratio, but with these ratios, uh, we are in grade 10, we are expected to actually know these ratios, because sometimes you'll find question that says solve this question without using a calculator. Maybe they say sine theta, and you are expected to know that sine theta is equal to 1 over 2. So you are expected to know these ratios. Familiarize yourself with this table. Familiarize yourself with this table, or rather, just familiarize yourself with these triangles that I draw here. One of the triangles is the 45 degrees triangle, and remember that the angles within a triangle always add up to 180. So you can either try to memorize the triangle here, of which we have two angles of 45 degrees, and that the two sides that are adjacent to the angles is 1 and 1, and then the hypotenuse side is root 2. And then you have the 30 and 60 degrees special triangle. It has the side of root 3 and 1, and the hypotenuse side is 2. So it's either you try to memorize the triangle, and then once we have the triangle, you can actually work out these ratios. So I think it's far easier for you to memorize these triangles than to try to memorize these ratios. Just know these triangles, know that okay, the adjacent side to 30 degrees angle is root 3, and then the adjacent side to 60 degrees is actually 1, and then the hypotenuse side. If you think about it, you only actually need to know these sides, these two sides, just know the adjacent sides to the English. If you know that the adjacent side to 30 degrees is root 3, and then the adjacent side to 60 degrees is 1, you can actually calculate this. You can calculate uh the hypotenuse side by using what the Pythagoras theorem, the theorem of Pythagoras, of which it says r squared is equal to x squared plus y squared, and then you solve for r, of which we'll get to. So even a much easier way, you know that all of the other sides is 1, are equal to 1, The sides, this is adjacent to 45 degrees, uh, and the side that is adjacent to 60 degrees is equal to 1. So all you actually need to know is to sort of memorize the side that is adjacent to 30 degrees, because it's the one that is sort of not normal. If you know, it's okay. The side that is adjacent to 30 degrees angle is actually root 3. Then you basically have figured out in a way these triangles, because it's okay. You're not gonna forget that the other adjacent sides are all equal to 1. The side that is adjacent to 60 degrees, of which is this one here, the side that is adjacent to 45 degrees, of which is this one here. All of those are equal to 1, so you just know the other three sides in the special triangle are equal to 1. So you only need to know this side, or sort of memorize this side, of which is equal to root 3. And then you can work out the hypotenuse side by using the Pythagoras theorem, of which is r squared, of which is r squared is equal to x squared plus y squared. So by knowing those special triangles, even in the exam, you can actually work out these ratios, by following SOHCAHTOA, so that is that, guys. And this here is the theorem of Pythagoras. Okay, and then in some instances, you are allowed to use a calculator when you are calculating or when you are solving trigonometric ratios or trigonometric expressions. You are allowed to use a calculator in some instances. But for the most part, we are going to use the Pythagoras theorem and the trigonometric ratios in order to solve those equations, and then we also introduce the 4 quadrants that we normally follow. It's simply a Cartesian plane with this quadrant here, first quadrant, second quadrant. We start from here, and then we move into the second quadrant, third quadrant, and then here we learned about the class method in order to learn which trigonometric ratios are positive in which quadrant. With class, you know that cos is positive in the fourth quadrant, and all trigonometric ratios are positive in the first quadrant. And it all comes down to you are in the positive x direction and you are in the positive y direction here. So everything is going to be positive. And then here it's only sign that is positive, and it's because you are in the positive y direction but negative x direction, of which by the trigonometric ratio of sine, of which is opposite over hypotenuse, it's y over r. Y is positive in the second quadrant and r is also positive. Actually, r is positive in all quadrants. So the only two sides that decide the sign, or the direct is the sign of the trigonometric ratio is the adjacent and the opposite side. Sorry, and then we introduced that. Okay, here we were doing questions. Okay, these are questions. We're gonna do more questions also. I would like for us to touch on these questions here to actually solve this. Just as a form of a recap, hopefully you guys did this homework. Okay, if we have time, we're also gonna answer it. We're also gonna answer that question, and then we introduce trigonometric functions. The 4 things that we are mainly concerned with when it comes to trigonometric function is period, domain, range, and the amplitude. So we have been talking about the period, and I have told you that for the sine and the cos function, 90% of the time in grade 10, the period is gonna be 360. And remember that when we were talking about the period, we were talking about how long does it take for the function to repeat itself. So as a good rule of thumb in grade 10, just sine and cos function has a period of 360, and then tangent function, the tan function, has a period of 180. And guys, please forgive me if I'm talking too fast. It's because I'm trying to just go through over this. I will send the notes, guys. As you know, I'm just going through over this so that we can get to so that we can have like more time so that we can have more time to do the questions, the questions, and so that you guys can actually see the application of these things, so that we can see the application of these things, you know. Excuse me. So here we're basically doing questions. It was questions. We talked about the amplitude moving from the center line to the highest point or the lowest point in your sine or cosine function. So that was the range, it's the y values. It's the y values, and then yes. Okay, so yeah, so today it's a revision. It's a revision. Today's lessons we start here. What have I done? What have I done? Okay. Okay. Let me just copy this, paste it. What's happening? I wanted to copy this. Okay. Yeah, this is the thing. Okay, guys. This paper is from 2015 DPE curriculum. Let's get into it. So I will explain. Uh, I will explain these. Uh, each of these concepts that we are going to encounter again and again as we are encountering them. Each time we're encountering, I will try to explain it again and then see the way that we are using it. So we start with okay, what's happening? 6.1. Write down the amplitude of f. So with the amplitude of f, remember we said it was this coefficient, but it simply represents the distance from the center line. It's too big. And this is not always the center line, guys. It's the center line by considering us moving from the lowest point to the highest point, and then we can simply add that and divide by 2 to find the center line, because you can find that your graph has been shifted, and now you have to find the you find the we have to find the amplitude. So it's not always going to be moving from the x-axis. Our graph can be shifted, and yes, we still have to find the amplitude. So what actually the amplitude does to the graph, it stretches the graph, because normally the graph of cosine will be within the range of what, of -1 to 1. But once if we introduce the amplitude stretches our graph. Maybe let me write that. I remember that we talked about the stretch a little bit, and we also talked about the shift. So when they introduce that coefficient to the cosine graph, of which is called the amplitude, uh, the amplitude stretches the the graph. So it basically stretches our graph. That's what the amplitude does to the trigonometric function. But okay, let's move on. This is 1 mark, guys. You should be able to answer it quickly. By now you should have an answer. I've already highlighted it for you there. I'll just say a is equal to -2. That is our amplitude. Okay. Now they are saying write down the minimum value of what? Of f at x plus 3. F at x plus 3. So what are they doing here? So here they are essentially shifting our graph now. Shifting our graph. Let's go. 6.2 f at x plus 3. But what is our f at x? Our f at x is equal to -2 cos x. So essentially we're gonna have this f at x is equal to -2 cos x plus 3. So right now what are they doing? They are shifting our graph 3 units up, because this is a positive shift. Remember that this value here that they introduce is what? Is a shift. So they are basically shifting our graph. The vertical shift. That's what that adding that number does to the graph. So If we know that our graph it has been shifted 3 units up, we simply come here. We start from the lowest, which is -2 plus 1 plus 2 plus 3. So our graph will now be sitting at what? At 1. At 1. So it will be like that, just a rough sketch because it has been shifted 3 units upwards. So what is the minimum value of this new graph here? It's gonna be what? It's gonna be 1. Minimum value is equal to 1. Okay. So what are they saying now? On the same set of x, draw the graph of g, where g is equal to sine x plus 1 for the interval of 0. Okay, so we're still using the period of 0 to 360 degrees. So, and we are asked to draw 6.3, 6.3, draw the graph of g at x is equal to sine x plus 1. Sine x plus 1. So when we are asked to draw the graph of sine or cos or tan, so I'm simply going to use this axis because we are trying for time. I'm simply going to use this axis. Even on the exam paper, this will be provided for you. We are using the intervals of 90 degrees. So you simply go to your calculator and put in sine 90. And you can already tell by seeing it, this plus 1 here. That's how our graph has been shifted what? 1 unit up. It has been shifted 1 unit up. So it's either it's going to start here, it's 1, or we will see, but it's just gonna be above that 1 unit. Okay, so here let me use a red one. That's our first point at 0. Oh, wait, I put sine 90. That's a mistake. This one is for 90. It's for 90 at 0. At 0, sine here is 1. Then at 90 it is 2. It's 180. Simply just use a calculator. It's 1 again here. Then we go to 270. 270. You can already see that the period is 360, even though it was not asked here, but that's just a general rule. Okay, sine 270 plus 1 is at 0. Is at 0. Okay. And remember, that's normally or usually when our graph has not been shifted 270, usually we find it here at -1, but here you can see that is at 270. Sine 360 plus 1 is 1. So that will be our sine graph. This is our sine graph. This is our sine graph, and you can tell here that our graph, if let's say there's this thing that they like to ask, whereby they say where our graphs equal, our graphs will be equal here and here. It's what's at 270, and it's roughly this is 90, somewhere here between 90 and 180. Between 90 and 180. It's 135. Yeah, the answer there would be 135, but I'm not sure if it's precisely 135, but if they were to ask where our graph are equal, but basically that will be your outcome for your graph, for your graph. So, and then 6.4, they are saying use the graphs to determine the following: f at 180, f at 180 degrees minus g at 180 degrees. So determine the value of f. Where is f as 180? Here is f as 180 is what? F as 180 is 2, and this new graph of ours, of which is the graph of g, it's 180 is what? It's 1. The graph of g at 180 is 1. um, sine 180 plus, yeah, so we simply take those values and put them there because they said we must use a graph. So f at 180 is what? It's 2 minus g at 180 is what? It's 1. So this is equal to 1. That is equal to 1. And then they're saying 6.4.2 for which values of x is x f at x times g at x greater than 0. F at x times g at x. So we have done a similar question to this one. And I remember so many ways to answer this one. So many ways. 6.4.2. So one thing you can do is to divide maybe with g at x. Not sure if that will change the inequality sign, but since they said use the graph, we're simply gonna use the graphs. So what we do here, we look at the scenarios that will essentially results in this value of f at x, f at x, f at x times g at x to be greater than 0. First thing first, any of the values here that we put cannot be equal to 0. Any of the values of f at x or g cannot be equal to 0 because now we're looking uh for those values of what of g and the values of f that will result in an outcome which is greater than 0. We're gonna use the graphs to determine this, so we're essentially looking for both positive f at x and positive g at x values because once we have positive f at x and positive g at x value x values, yes, but okay, I'll just put f at x for the distinction. This is the only condition that will give us a number that's greater than 0, if both f at x and g at x are positive. So whenever we go to the graph and maybe we find that g at x is negative, so negative times positive is going to result in a negative, which is a number that is less than 0. So that's not going to work. That's not going to work. So let's go. Okay. Let's come here. When we come here from 0 to 90, you can see that f is negative here, negative f, from 0 to 90, so automatically that side is out. And then let's come here also once again. I'm sorry, I want to use the highlighter. Once again, f from 270 to 360, f is what? Is negative. F is negative, so that is also automatically out. So we are mostly concerned about the graph of f because we can see that the graph of g is above the graph, sorry, is above the x-axis, so it's above 0 in a way. So all of the values of the graph of g are positive. So that's why we're mainly concerned by the graph of f, you know. And then another thing here, at exactly 90 degrees, the graph of f is equal to 0. So we have to exclude what? 90 degrees. And also the same applies here at exactly 260 degrees, sorry, 270 degrees. Both the graph of g and the graph of f are equal to 0. So that's one apply. So essentially, it's only going to be these values. It's only going to be these values, how do I put it, above, where x is above, x should be x should be above 90 degrees. X should be above 90 degrees, but x should be less than 270 degrees for this to be true. For when each time we multiply f at x by g at x, for us to get a positive value or a value that is greater than 0, this condition has to be met, so maybe let's rewrite it. X is greater than 90 degrees, but X is less than 270 degrees. So that is your answer. That is your answer. Okay, so another thing, they say the graph of F is reflected about the x-axis and then moved 3 units downwards to form the graph of H. Determine the equation of H. So remember what we have learned before. That's when we are flipping a graph. What do? We simply introduce a negative sign. If we want to flip or to reflect, excuse me, the graph, we will say what? Negative FRX. That's how we reflect the graph about the x-axis, and then what they did, and then moved 3 units downwards. Then minus 3. Then minus 3. This is how we flip the graph of F. So if we were to write the equation of HRX is equal to minus 2 cos x minus 2 cos x. Oh, it's already minus, so it's negative, minus 3 units downwards. So that is how we basically gonna flip the graph of F to get the graph of H minus 3. So that is your outcome right there. So it's just that right now we are trying for space, hence why I'm writing it here. But yes, this is your outcome. Maybe let me put it neatly. Yes. This is 6.5.1, and then next thing they're asking for the range of H, for the interval of 0. Okay, the range of H. So essentially what they did, they took this graph, and then it was shifted 3 units down. 3 units down. So we started by flipping it. So when we flip it, it was basically something like this now, and then we shifted it down 3 units. Let me see. Okay, it's not bad. Um, it's not bad. So we flipped the graph. Let me just say this graph of H. The one in blue, this graph of H. We flipped it. That's the first thing we started by doing, by introducing that positive sign, and then it was shifted 3 units down. Let's shift it 3 units down now. We will move from here. It's 1, 2, 3. So it will start at -1, going 3 units down. So the lowest of the lowest will also okay, let me do like this. Copy. Sorry to write on top of this, but I want you to visually represent this thing for you. So it's 1, 2, 3. 3 units. So it will start from -1, and then also it has been shifted 3 units. The lowest value was -2 here. So from -2 to -3, it will be at somewhere down here. It will be at what? -5. But you can simply just punch it in your calculator. Say -2 -3, you get -5. It was shifted to -5. So the range would be now what? -5 to 1. -5 to 1. 6.5.2. the range of h. Okay, y is the element of minus 5, or square bracket since it's a number, 2 to minus 1. That is the range of h after it has been reflected and then shifted. The range of h. So we're able to fit all of these things in one page. So I don't know if guys, if is there any of you that has questions regarding what we have just done here. If you do have questions, you can speak now, or we can move into the next question. I want us to do as many questions as we can today because essentially want you to learn to apply these things. To apply these things, you know. Ish, trying to move this thing. So from your silence, I guess everyone is okay, guys. We're gonna move into the next question. We're gonna move to the next question. Okay, so we have two same things here. I don't know how did we end up getting to them, but again, it's okay. We'll deal with it once we get there. Let's go ahead. Alongside is the graph of the function of f. So it FRA sine x. A is what is our amplitude. Remember, A is our amplitude and it's used to stretch our graph. This is our amplitude here. We said we move from the center line to the highest point. You can already tell it's 2. Okay. Oh, and that is actually your first question. So another thing that's I've been emphasizing, guys, is that it's very important that um you once you get a question, just start writing down what you already know. That will save you a lot of time, because by the time you get into answering the question, you could have already have answers. So if you know that the amplitude is the stretch, or is that value when you move from the center line to the highest value to the lowest value of our function, you simply write that down. So 1.5.1, 1.5, what is the value of a? They're asking for amplitude. Let me write amplitude. What's the value of a is equal to 2. Let's move on. We have talked about amplitude. What are the coordinates of a? Okay, now the big A, the turning point of the function of the f at x shown on the graph. So for this function, we have been given that's what we have been given minus 2. That's the value we've been given, essentially the y value for this function, but we already have a. So we can use the, what you call this thing, we can use the, by just substituting these values here that we already have, we can find the turning point here. Or with the graph, if you are really really if you are really lost, let me just say that, you can sort of estimate, that's gonna be, it has to be 270, if I'm not mistaken. It has to be 270 because it's around this value here. So it's gonna be 270 and minus 2. Those are the coordinates of a. But let's use the function that we have. F at x is equal to, say, a is equal to what? 2 sine x. We are looking for the x value, but for the f, it's already given there. The turning point is what? It's minus 2. is equal to 2 sine x. Then we divide by 2 on both sides. X is equal to sine inverse -1 equal to 270. You can punch on your calculator to confirm that. So the coordinates of A is what? Is 270 degrees and n-2. Well, we were not given the degrees. We'll just say 270 and -2. Those are the coordinates. What is the period of f at x? What did I say? For grade 10, just stick with 360 degrees. Even if you don't know the what you call this thing, the period is just gonna be 360, because your graphs hasn't been like squeezed or stretched horizontally. It's only stretched vertically. So for the period, it's always gonna be what? It's always gonna be 360. Period is equal to 360 degrees because it's a sine function, and the cos function is the same also. For the cos function, it would have been the same. For the tangent function, we said it's equal to 108. Okay, what would be the new equation of grx if grx is obtained by shifting f at x up by 1 unit? So we are now shifting the equation, sorry, the equation of f. So they say it's up, so we're adding it's f plus 1. So let's come here, grx. We know that the equation of f at x is equal to what? 2 sine x. 2 sine x, then we add 1. So grx is equal to 2. Okay, this is essentially the equation, 2 sine x plus 1. I don't know why did I have to write it again, but here is the equation. If we are shifting the function of f at x by up by 1 unit. So that was quicker. That's why, well, it's 5 marks. It's 5 marks. I don't think there's anything trick about this particular question. So I don't know if you have questions regarding something I've just mentioned here. You are welcome to ask, or I will move on to the next question. To the next question. Okay, I want us to finish the functions first. Okay, so here it has been doubled. I want us to finish functions first before we go back to this trigonometric equation delays. Yeah, we're just gonna do the function equations, and then after we are done with the functions, we'll start doing these equations. We'll start doing these expressions. But for now, we'll just do the functions, and then yeah, but we are gonna do the revision for those ones also. We are crunched for time, so let's move ahead. This is our next equation, so we're gonna do this and then do this one, and then move to other parts. So we're just gonna deal with functions because it's what we were doing recently. So 6.1, question 6, consider the function of y is equal to 2 tan x, and we're asked to make a neat sketch of y is equal to 2 tan x for 0 degrees, okay, for a period of 360 degrees on the x-axis, provided on the diagram sheet 1 clearly indicates on your sketch the intercepts with the axis and the asymptotes. So here we are dealing with the function of tan, and we know that with the function of tan, it's normally undefined at 90 degrees and 270 degrees, so those will be your asymptotes. But maybe let me start here just like I did on the other one. 6.1.1, we are going to sketch our function. We are going to sketch this function of tan. Let me just say 1, 2, 3. 1, 2, 3. 1, 1, 2, 3. 1, 2, 3. And then they said what? Or another thing that we normally do for the sine function. Remember that I said for the cos and sine function, we normally use the intervals of 90 degrees. For the tan function, we normally use 45. So it's gonna be 0, 45, 90, 90, 135, 180, 225, 270, 270, 315, and 360, and 360. But I'll only write for 90 degrees, 180 degrees, 270 degrees. Just for neatness, I'll only write these values. And then here we have 1, 2, 3, minus 1, minus 2, minus 3. We were asked to do an case. So from there, you just take the function as it is, you punch it in your calculator, you get the values. 2 times 0, 2 times 0, it's 0. Let's go to 45. 45 is 2. 45 is here. It's 2. 2 times 45 is 2. And then 90. 90 is our asymptote. You are carrying an error there. So our graph will never touch this value. Okay, from 90, let's go to 135. From 135, we're carrying a minus 2. And then 180. 180 is 0. 225 is 2. 225 is 2. 270 is again our asymptote. Is the asymptote. Our graph will approach this value, but it will never touch it. Asymptote. Asymptote. We don't touch that value. 270. Okay, so next is 315. 315 is minus 2. Is minus 2, and then lastly 360. 360. And guys, it is advisable for you when you are actually in the exam to write all of these values. Let's I've left out those 45 degrees, 185, all those values. Just write everything down when you are in exam. For me, I just left it out for neatness. Our graph is gonna come out. It should be a curve. Let's see, just what I'm trying to avoid. Yeah, it should be. I'm trying to draw it as neatly as I can. Ready. Now it's a very good curve. But again, I'm just trying to draw this graph as neatly as I can. As neatly as I can, even though it's not as good because last time I drew this other one, it was very, yeah, it should be something like this. Just move this one. here for this. We'll just assume that it's here, just for the sake of neatness, guys. You know, um, uh, so our draft would be something like this. It's just that this one is ugly. Or maybe let me do this thing. Let me move it a bit down so we can have space to do this thing nicely. So yeah, something like this. Yes. So this will be your draft, guys. This will be our draft here. Just mind the asymptote that the graph will approach the asymptotes, but it will never touch them. That value at 90 degrees and 270 degrees is very important that you show those values when you are drawing your graph. They allocate marks for that. They allocate marks for that, and then your intercepts, where our graph cuts here. At 8, it's 3, 6, that's 0. Those are intercepts. And then yeah, once you draw your graph, yes, and then this is x-axis, this is y-axis. You would have your marks. Okay, what are they saying from there? If the graph of y2 tan x is reflected about the x-axis, write down the new equation for the graph obtained by this reflection. This is 1 mark, guys. I'm pretty sure right now we are familiar. We have been talking about reflection. Sometimes it can be said it's if it's mirrored, if it's flipped, or reflected. They like to use the word reflected. You simply introduce a negative sign there, on your graph. So the graph of reflection is gonna be y is equal to -2 tan x, -2 tan x. So that would be your graph of reflection, -2 tan x, and it's gonna look something like this. If let's say you were to draw it, it's gonna look something like this, you know, something like this. That would be a graph of if it's reflected. Actually came out better even then. Came out better than the original one that we had. That's your graph of reflection. That's your graph of reflection. You know, if we just introduce that sign there, we're gonna get this graph. It has been reflected about the x-axis, you know. And then let's go to 6.2. 6.2. 6.2. The diagram below shows the graph of GRX is equal to A sine X. A is our amplitude for this period. You can already set here it's gonna be 4. Okay. So the thing about the period rules, you can always just read it off from the graph, hence why you'll see that for most part they just allocate 1 mark for it because it's something, it's either we're gonna read it off from the equation or from the graph. It's so A here, A amplitude is equal to 4. It's the highest point from the center line. Always remember the highest point from the center line. So here it's 4. It's the highest point or the lowest point from the center line. So when do we pick the highest point? Maybe I need to address that also. If our graph starts here from 0 and essentially goes up like this into the positive, then we're gonna pick the highest point. But let's say this graph was flipped, was flipped about the x-axis, and then it was something like this. It was something like this. Then our amplitude was gonna be what? It was gonna be -4. Just know that it depends on where our graph starts. Let's say if it was a cosine graph, it was a cosine graph. If it was a cosine graph, maybe starts here. Ish. Maybe it was a cosine graph, something like that. But it starts from below. Even though the center line is still the same, start from below. The amplitude here was gonna be what? Was gonna be -4. But if maybe it was a cosine graph like this, starting above, the amplitude was gonna be what? It was gonna be 4. So that's also very important when we are dealing with the amplitude. With the amplitude. So if the graph of G is translated 2 units upwards to obtain a new graph of H, write down the range of H. So we are essentially shifting this graph of G 2 units upwards. So it's 1, 2, 1, 2. Our new graph is gonna be starting from here 2, and then sorry. What am I doing here? Starting from 1, 2. It's gonna be something like this. Something like this. We are shifting it 2 units upwards. Yes, it's not as good, but you get the point. We're adding 2. We are shifting it 2 units upwards. It's 6.2.1 here. The amplitude 6.2.2. Translated 2 units upwards to obtain. So we're asked the range. So here, in order, easiest way to determine the range, if your graph has been shifted 2 units upward, to go here to the range. Let's start by writing down the range of the graph of H. The graph of H. Y is the element of it starts from -4 to what? To 4. To 4. That's the range of the graph of um of H. So sorry, this is the graph of G. This graph that we have here. And then so if we are shifting it 2 units upwards, it essentially means that our range is gonna start 2 units higher than this range of G, and then it's gonna also close higher than this range of G. So we're just gonna add 2 here and add 2 here. So the new graph of H, I'll just say range of H, range of H. So that's the simplest way of actually finding this. We just say y is the element of -4 plus 2. We're shifting it right 2 units upwards, and then 4 plus 2. Therefore, y is the element of what? -4 plus 2 is what? -2. And then 4 plus 2 is 6. That is the range of this new graph we are being asked about. The graph of H. That's your range, guys, So this is 8 marks. This is how you get your 8 marks. If there is any question, please unmute yourself and then just ask any question. If there is no question, I'll move on to the next question. The goal for today, guys, was to do as many examples as we can. So any question, guys? Okay, since there are no questions, I'll move forward. Let me see how many functions. Okay, seems as if we're left with only one function. So guys, we have covered quite a few important things, that you need to know about trigonometric functions. That is your period, amplitude, amplitude, range. You're not gonna be asked about the domain that much, but period, amplitude, range. What's the next thing? Shifting, reflecting, reflecting, and what else? What else? Yeah, I think that is that. And then we just play around these things. So these are the key things that we essentially are expected to know as trade 10 mathematics students, for when it comes to trigonometry. These are the things that we're expected to know. I said period is the time it takes for the graph to repeat itself. The amplitude is the highest point or the lowest point from the center line, depending on when we start. Uh, and then shifting or the range, we know that's the y values for the graph. Shifting, we simply is q here that they add here. That q, that's your shifting. Stretching is that a, that's for amplitude. That's for amplitude. So let's go ahead. Let's go ahead. Um, let's go ahead. Let me see something here. It was y minus 2. Okay. Then x minus 2 tan 45. Oh, this one was shifted. True. Let's go. So, it's 8 marks. Once again, 9.1. 9.1. Write down the period of the graph of f. What did I say? The graph of f is what? It's a tangent function. What did I say is the period for the tangent function? For the tan function. I've told you multiple times that it doesn't change. 90% of the time you're just gonna have this same thing. Period is equal to 180 degrees. It takes 180 degrees for the tangent function to repeat itself. That's your period. It's 180 degrees. For the sine and cosine function, the period is 360 degrees. Determine the value of q for the cosine function. The cosine function here. So you can see it with the cosine function here that it has been shifted, shifted down. The cosine function, it has been shifted down by what seems to be 1 unit. 1 unit, because we normally have been like, yes, that's the cosine function. So it has been shifted by 1 unit. Cos 90 and 0. So, right, determine the value of q. So if our graph has been shifted down by 1 unit, that means the value of q is equal to what? Q is equal to -1. As you can see, that graph has been shifted by 1 unit. And now we're asked to write down the value of a for the tangent function. So we are looking for the amplitude. For the amplitude of the tangent function. And remember, I think we said something about the tangent function not having uh, corners, not having an amplitude. Not having an amplitude because it's basically it goes into in the range of this thing. It goes into infinity. From negative infinity to positive infinity. But just because we said it didn't have the amplitude, this is to imply that the tangent function is continuous. It continuous. It goes basically until infinity. But it does have that coefficient. We can have a coefficient that will simply, if we introduce a coefficient next to a tangent function, let's say a tan x, it will simply just stretch this function. You see here with this tangent function that at 45 degrees, this is a simple tangent function here. Let's say that one is y is equal to tan x. At 45 degrees, if we were to say tan 45, it's equal to 1. As you can see here graphically, it's equal to 1. But now, if now we introduce the value of a here, it's gonna stretch this function. Let's say we say now we introduce a value of a that is 3 tan function. 3 tan 45 is no longer at 1 now, but it's gonna be at some value here at 3. So you can see, by introducing that value, that is our stretch. That is our stretch. The tangent function will be stretched by this value that we introduce here. It's not necessarily an amplitude, but a vector which stretches our tangent function. So essentially we are asked to find that value for this tangent function we are dealing with um here. Write down the value of a 9 plus 3. So you can simply solve, if you remember functions, we can simply just take these coordinates here or these coordinates here. Remember that we have the coordinates of what? Of 45 degrees and what? And 1 and 1. 45 degrees and 1. So we can simply take these two values and substitute them to this tangent function in order to solve for what? For a. Let's just do that. Let's just do that because I want you not to claim these things, but to actually have tools to answer these things once you are in an exam. Because sometimes you will find the value of a here it will be 1. But you can find that the amplitude or the not the amplitude, but the tangent function has been stretched. If this function was stretched, the value of a was not gonna be 1. But for this one, it's clearly gonna be 1 because it's not stretched. But let's go ahead. Our f is 1 is equal to a tan 45 degrees. So you already know with trigonometric ratios, tan 45 is equal to opposites over adjacent. 45 over it's 1/1 if you remember those special triangles. But you can put it on a in your calculator. That's gonna be 1. Therefore a is equal to 1 over tan 45. Tan 45 is equal to 1. So a is equal to 1. There you have your a. It's 1 mark. You could have just read it from here and so that it's a. But even if you solve it like this, I would prefer for you to uh know how to solve these things just the way I did, because sometimes it can be stretched and the value of a would change, and then you'd have, of course, a little bit more marks for that, if that was the case. But yes, that is it. What is the range of g? The range of g, we are looking at the y values. Our g starts from here to here. So as you can see that our graph starts from -2 to 0. That is our cosine function. So sorry, y is the element of -2 starting with the low value to what? To 0. That is your range. Determine the x values for which g of x is greater than f at x, 4 minus 80 to 0. So it has been specified that we're only going to look from minus 180 to 0. We're not considering anything from 0 to 180. Just those two things. This is our graph of g here, and then this is our graph of f. Here we have our asymptote here at 90. The graph of f is the graph of f doesn't touch them. So you can clearly see that from minus 180 to 90 degrees, the graph of f, this graph here, is clearly above the graph of g. It's clearly above the graph of, so the statement doesn't apply. But from here, from 90 degrees to 0, it's actually the graph of what? It's now the graph of g is above the graph of f. So here our statement is gonna hold true, because this graph here, this graph of g, is now above the graph of f, and up until 0, whereby it is actually equal to whereby it is equal to 0, and these two graphs are equal, so that will be inclusive, of course. So where x where x is greater than where x is greater than 9 minus 90 degrees, where x is greater than minus 90 degrees, and where uh, x where x is uh, less than or equal to 0 degrees, so x is greater than 90 degrees but less than or equal to 0 degrees. So this would be your final answer. Those are the values whereby the graph of g is greater than f at x. We determined that graphically, and it was specified as only from here to here, so we're not looking at this point, we're not looking at this point, or from 0 to 180 degrees. Okay, guys, I think this marks the end of the functions. If there's any questions, please speak now before we essentially move on to doing the trigonometric ratios and the expression. Okay, this one is long, I think. Maybe we're just gonna do it, and then yeah, because our time is about to end, and then I'll just leave the other ones as homework, you know as homework, or I'll do them. Yeah, I'll leave them as homework. You guys will do them, and then I'll upload the work solutions. But for now, since we still have time, let's answer this one, question 5. So we are going back to trigonometric ratios using Pythagoras theorem, all those stuff. We are going back to that now. We are going back to that. I think with trigonometric functions, you guys should be sorted. If you have anything or any question in regards to trigonometric function, please ask the question now. Please ask the question now. You can send the question of the group if you are ashamed to ask the question. But yeah, we have covered basically all of the important things in regards to trigonometric functions. Okay, so I will take your silence as if there is no question. Right now we can move into answering this question 5 from 2015. So in the diagram below, um p at x and y is a point on the third quadrant. Okay, p and x and y is a point on the third quadrant. If it's in the third quadrant, then x is negative and y is negative. Just to note a few things. And in the third quadrant, we remember the cast method. Cast, cast. So it's only time that is positive in the third quadrant. So we already know that since we are given a cos there for this beta, um the ratio of course would be negative there. Okay, but let's go ahead. So and cos, okay, rop is equal to beta rop rop. Okay, I don't know why they put that thing like that. Rop is equal to beta and 17 cos beta plus 15 is equal to 0. Write down the values of x, y, and r. Let's go ahead, guys. 5.1.1. What are we given? 17 cos beta plus 15 is equal to 0. Is equal to minus 15 divided by 17. So essentially cos beta is equal to minus 15 over 17. And remember that cos, let's bring back the SOHCAHTOA. SOHCAHTOA. So cos deals with what? Adjacent and hypotenuse. Adjacent, how do you adjacent over hypotenuse. Adjacent over hypotenuse. So we already know that 17 is equal to r, and that's minus 15 is equal to x. So essentially, since x is our, if we were to draw this, x will be the adjacent side to p, and then y, as you can see, is opposite to beta. So our x is equal to minus 15, and then our r, the hypotenuse, is equal to 17. And then in order to solve for y, gonna say r squared is equal to x squared plus y squared. So 17 squared, 17 squared, should we solve it by the angle first? 17 squared plus minus 15 squared plus y squared is equal to 17 squared minus 15 64. That's 8. Okay, so we're gonna have 17 squared minus 15 squared. So we know that if we square this negative number, it's essentially gonna result in a positive number. So it's 15 negative times negative, it's positive. So hence why I didn't include the negative sign again here. Y is equal to, so this is equal to 64. Everything here, if you punch it in a calculator, and then to remove the square roots, sorry, to remove the power of 2, we just introduce the square root on both sides, and then now we are left with 8. Square root of 64 is 8. But then you can see that y is in the negative direction, so y is gonna be equal to minus 8, since it's in the negative direction here. We are getting a y is equal to minus 8. Okay, so next thing, they're saying without using a calculator, determine the value of sine theta. Okay, a 5.1.2 a sine theta is opposite over hypotenuse. Our opposite side is what? Is minus 8 over hypotenuse. We said it's what? It's 17. Is 17. That's your answer. Then for P, cos squared 30 degrees times tan beta. Tan beta, it's we are in the third quadrant whereby tan is positive. So essentially here we have cos 30 degrees squared, So cos 30 degrees, if you remember, is root 3 over, it has to be root 3 over 2, if I remember the special triangles. Cos 30 degrees, yes, it's root 3 over 2. Root 3 over 2, that's your cos 30 degrees. So let's come here. Where were we? Okay. It's gonna be root 3 over 2. This is just a simple trigonometric ratio squared times tan beta. We have our beta there. So we're still dealing with the ratios. There's no need to use a calculator here. Our opposite is what? It's minus 8 over our adjacent of minus 15. So it's gonna result in a positive answer there. So we're gonna have root 3 over 2 squared. So it's basically 3 over 4 times 8 over 15, and the answer is 2 over 5. 2 over 5. Okay. And then they say calculate the size of ROP correct to 2 decimal places. And remember that they said ROP is equal to what? Is equal to beta. Is equal to beta. So we essentially ask to calculate the value of beta. And right now we are gonna use the what's it called this thing? The calculator, since it says correct to 2 decimal places, Or maybe let me do like this. I'll just place this one where I'll just place it here, and then move this one up, trying to trade some space for 5.1.3. 5.1.3. uh, so we're also calculate the size of so we can essentially just use that what we call this thing, cost ratio that we were given there, because remember they said ROP is equal to pizza, so we're just gonna calculate the angle of pizza. So 17 cos pizza plus 15 is equal to 0. So we transpose 15 to the other side, cos pizza is negative 15, and then we divide by 17 on both sides, and then pizza is equal to cos inverse minus 15 over 17. Put that in the calculator, get the value of pizza, which is essentially equal to the value of ROP, cos inverse minus 15 over 17. Pizza ROP is equal to 151.93 degrees. Please punch your calculator and confirm if you have different answers from me. Maybe I made a mistake somewhere. Okay, and then for the last three questions, we are gonna gonna copy, solve for x, so it's basically solving for x. Okay, um because of time I can see we covered functions. We are not gonna be able to finish this one, so this will be your homework. I'll send worked examples for this. This also be your homework. But guys, this one we covered it like a lot. These trigonometric ratios, we covered them a lot. So please do these things. For your own benefits. Please do them. Let's finish doing. So it's 5.2. For the following equation, solve for x, where x is okay. Give your answers correct to true. X is between 0 and 90 degrees. So our first one is 5.2.1. 10x is equal to 2.22. Therefore, x is equal to tan inverse 2.22. X is equal to 50 tan 2.22. X is equal to 65. But that's in your calculator. 0.75 degrees. Okay, 5.2.2. We are given a second sec x plus 10 degrees is equal to 5.759. Remember that sec is the reciprocal of um, where do we deal with reciprocals? Sec is the reciprocal of what? Of cos. So that is basically 1 over cos. 1 over cos is equal to sec. Where is this thing we're doing? So this is essentially 1 over cos x plus 10 degrees is equal to 5.795. We multiply by that cos on that other side, then we divide with it again. So cos x plus 10 is equal to 1 over 5.759. X plus 10 degrees is equal to 1 over 5.759. X plus 10 degrees is equal to, you punch this in your calculator, shift 1 over 5.759 is 80.00 degrees. So we said x is equal to 80 degrees minus 10 degrees. Therefore, x is equal to 70.00 degrees. We say correct to 2 decimal places. There we have it. And then 5.2.3, 5. So this is basically solving for x now, guys. There's nothing special about this. 5.2.3. Sine x over 0.2 minus 2 is equal to 1.24. We transpose the 2 on the other side. I'm going to say sine x over 0.2 is equal to 1.2.4 plus 2, and then we times by this 0.2. It's going to be sine x is equal to 3.24 times 0.2, and then x is equal to 0.24 times 0.2, 0.648. X is equal to sine inverse 0.648 is equal to answer 40. Okay, is equal to 40.39. 40.39 degrees. So this is it, guys. This is it. This would mark the end of our session. We went above the time because I wanted to finish this question. So guys, if you have any questions concerning what we have done today, where you need clarification or compliments, yes, now is the time. Now is the time. Now is the time. Or unless you can just send the questions there at the group. Anyway, yes, this marks the end of our session, guys. There's no question. Thank you so much for joining us today. I will share the notes in the group, and then we will take it from there. Enjoy the rest of your day, guys.